In this lecture, we'll focus on lung volumes and lung capacities. Let's start with the anatomy of the lungs. So in the lower respiratory tract, there is trachea, which divides into right and left bronchus into the lungs. These bronchi, they further branch into bronchioles. At the end of these bronchioles, we have a sac of alveoli. And the main function of the lung, that is exchange of oxygen and carbon dioxide, occurs between these alveoli and blood. Lung volume or respiratory volume is the volume of the gas in the lungs at a given time during respiratory cycle. And lung capacities are derived by adding 2 or more lung volumes. It is important to understand lung volumes and capacities because they form an important part of pulmonary function test. And pulmonary function tests are required to diagnose and differentiate different respiratory diseases, specifically obstructive and restrictive lung diseases. Let's start with lung volumes. So think of this as your lung. Now the volume of air that you are inhaling and exhaling with each breath at rest is called tidal volume. And it is equal to 0.5 liters or 500 milliliters. Now if you're asked to inspire forcefully with extra effort, then that extra air that will enter your lungs after the normal tidal inspiration is called inspiratory reserve volume, and it equals approximately 2.5 liters. Conversely, if you are asked to exhale forcefully, then that extra amount of air that leaves your lungs after normal tidal expiration is called expiratory reserve volume, and it equals approximately 1.5 liters. Even though you have made an extra effort during expiration, one cannot throw out all the air from the lungs. So there is some air which is still in the lungs after maximal expiration. That is called residual volume, and it is also approximately 1.5 liters. Now that you know the 4 important lung volumes, let's add them up to derive different lung capacities. First one is inspiratory capacity, which is derived by adding inspiratory reserve volume and tidal volume. Inspiratory capacity. So we remember that inspiratory reserve volume was approximately 2.5 liters, tidal volume was 0.5 liters, so that means inspiratory capacity equals 3 liters. Next is functional residual capacity, which is a sum of expiratory reserve volume and residual volume, and it is also approximately 3 liters by adding 1.5 plus 1.5. Vital capacity is a sum of inspiratory reserve volume, tidal volume, and expiratory reserve volume, and it equals 4.5 liters. Finally, we have total lung capacity. As its name suggests, we will add up all the 4 lung volumes to obtain total lung capacity, and it will come approximately 6 liters. Let's plot these volumes and capacities on a graph. So on x-axis we have time, and on the y-axis we have lung volumes in liters. So this is a person who is breathing normally at rest, in and out, which is tidal volume. Now if that same person takes a deep breath in, inspires forcefully, then that's called inspiratory reserve volume. Then we ask that person to exhale forcefully, so he breathes out. This is expiratory reserve volume. And then there is some air which is still left in the lungs after maximal expiration. That is residual volume. Now let's go through lung capacities again on this graph. First one was inspiratory capacity, which we said was the sum of inspiratory reserve volume and tidal volume, right? The second one was functional residual capacity, which was the sum of expiratory reserve volume and residual volume, right? Next is vital capacity, which we can get by adding inspiratory reserve volume, tidal volume and expiratory reserve volume. And finally, total lung capacity, which is the sum of all four. Understood? And this is the better version of the graph which you will come across in your textbooks, and I hope that you won't find it difficult to understand after this lecture. And that's it for today. In the next video we'll discuss spirometry and how it relates to these lung volumes and capacities. Thank you for watching the video. Take care. God bless you all.